Alright, so we're back with Mr. Jeffrey's Algebra 2 class. Don't forget, hit subscribe, hit the bell, and thanks for everybody that's already subscribed. We're already at 51. Wait, there we go. Woo! Alright, so, yeah, what is it? Smash that like button. Okay, so these problems from this warm-up is a condensed version of what we did yesterday. So if you were not here yesterday, it's a good review. And if you were here yesterday and totally didn't know what was going on, it's this thing right here. Now, standard form of a function is the highest exponent to the smallest. Now, I did realize afterwards that I did not give y'all a whole lot of room to actually write these, but let's look at them. So our highest exponent is negative 7x to the 6th. And marking you out. Lost my cursor. Negative 5x to the 4th. It's a cursor. X to the 3rd. And what's funny is that these last three terms right here, they're actually in order as we would write them. Now, it's kind of funny that it just kind of like goes up, like, but you know, whatever, roll tide. Okay, so the degree. Now, remember in this class, I'm not asking you to remember linear, quadratic, cubic, quartic, quintic, and I think it stops right there. We just actually have to do the number. We're just going to do a degree of 6, okay? And I actually think that's the true mathematical thing. It's like the 6th degree. It's kind of like, you know, Chuck Norris's left pinky is a 15th degree black belt. So, you know, something like that. The number of terms, remember it goes, you know, mono, bi, tri, and anything over 3 is a polynomial. So this one will definitely be a poly. Now, the next part, I think y'all kind of got a little bit better yesterday, but we'll see. We have to look to see if our degree is even or odd. Well, our degree is 6, so this would be even. Okay. The LC, that's the leading coefficient. That's actually this number right here. Well, is it positive or negative? Well, this is negative. So we have these things of how this graph looks at the end. You know, the left end of the graph, the right end of the graph. And unfortunately for those at home, you can't see what I have written, but you can easily Google that. It's no problem. All right. So we have an even and then a negative. So on my board, it's over here. It's actually in this turquoise color that as f of x will approach negative infinity as x approaches negative infinity. That basically means on the left-hand side, it's going down. All right. On the right-hand side, this goes to negative infinity as x gets bigger. So the graph of this looks something, I can't exactly remember what to the 6th power looks like, but it looks somewhat like a quadratic that opens down. Excuse me, because this is negative, okay? Now, this is very similar to what I'd probably have set up on the test, and this is why. I can actually ask, basically, that whole question covers everything we did yesterday, except for plugging something in, and I don't think I really want to test that because that's really easy, okay? This other stuff, I like it getting knocked out of the way, okay? So, let's look at number 2. Look for the big one. All right, so we have 4x to the 5th and minus 3x to the 4th minus 2x cubed. Now, I had a few people ask, they're like, wait, there's 2x squareds. Well, we would actually combine those. So 5x squared plus 12x squared is actually 17x squared. And that's actually something we're getting into today. That's why this problem's on here. Okay. It's not by, oh my gosh, I can't see stuff. All right. So that goes here, and this is minus 4. All right. Yet again, Mr. Jeffries did not give you a lot of room to write, but I can fix that. Now, the degree. What's the biggest exponent we have right here? 5. And we have more than 3 terms, so this would be another poly. Okay. Now, our degree. Is our degree even or odd? Odd. Okay. Is the LC, this number, is it positive or negative? Yeah, it's positive. So when our degree is odd and our LC is positive, for those in class, this would actually be what is on the top in blue right here. All right, so it says that it goes negative infinity as this goes to negative infinity, and this goes to positive infinity. Ooh, that looked bad. Looks like googly eyes back at me. As this goes to positive infinity. Because this graph kind of looks something like this. Okay, and that would kind of make sense. As the further we go to the left, it keeps going down. The further we go to the right, it keeps going up. Okay. And somebody asked in the last class, they said, "Are we going to have to graph these?" I said, "What's Mr. Jeffrey's theory on graphing stuff?" You said you don't like it. I said, "Exactly." Okay. That is an archaic thing to graph this stuff on paper. We have tons of different technological things that we can do that will graph it for us. Okay. So, yeah. And honestly, there's tons of people that use some of the simple stuff that will actually do all this for us. And somebody said, "Well, why don't you make us graph it and like upload the picture?" I said, literally, I would get, say, I have 60 Algebra 2 students. I'd get 60 exact same copies. Like literally one person could get it and send it out to the class, and it would all look the same because that's how it's going to look online. Okay, that's, huh? Yes. So we said the question was, how do we find the left and the right of the graphs? So we use this right here, that the degree is odd and our leading coefficient is positive. We see which one that those fill into, and that's how we get those answers right there. Okay, it's basically which category does this fit into? Do you remember the other day when y'all were doing categories of anime that Mr. Jeffrey should watch and categories that Mr. Jeffrey should not watch? Basically the same thing. Which category does this problem fit into? Now, when it says left, it's as like if this is our y-axis is as we go this way or as we go this way. Does that make more better sense? All right, much more better sense. Woo, moving on. All right, adding and subtracting polynomials. You can only combine like terms with the same variable and same exponent. Now, here's the key. You're only adding or subtracting the big numbers. You're not doing anything to the exponents. Now, Mr. Jeffries is a little unique. We all know this. Okay, I like using symbols to mark my like terms. Okay, now I put a square over the square terms. Yes, very basic. Thank you. Now, negative 6 plus 10 is the same thing as 10 minus 6, which is 4. So we just have 4x squared. Okay. 3 plus 4 is 7. Somebody said 6, and I was getting kind of worried. Remember, use of calculators are encouraged. All right. And I usually underline my constants. That's just me. Y'all can do whatever. Okay. and I'll have -7 plus, -7 plus -2, which ends up being -9. And that's actually the answer for that. Okay. Yeah. I know some people are like, wow, this is kind of easy. I'm like, well, yeah. And then everybody's like, there has to be a catch. This has to get harder. Well, not really. The only thing that makes this harder is that there's so many different terms. And that's why I said, make sure that you can use symbols, or I have some students, they'll get the colored pencils and they'll do it. Some people do highlighters, your gel pens. I don't know, whatever you want to do. Potato, potato. Okay. Now, I didn't put these terms together because sometimes for adding, and these aren't as bad as the next ones. What I mean as bad as multiple terms, you can, you might be able to see it a little bit more. So I'm scanning. It looks like my biggest thing is to the fifth power. Okay. So I don't have any other thing to add to it. So there we go. Now, I like using little pyramids over my fourth. Okay. So we have 10 plus -5, which is the same thing as 10 minus 5, which is 5. Yes, good. Whew. That wait time, man, it's like makes my heart cringe. Okay. Our next one looks like to be x squared. Do we have any other x squareds? No. So there we go. I have -5x plus 2x. Well, if you're not good at science, you can use your calculator, or you can do the old thing, subtract the numbers, keep the sign of the bigger one. We'd get -3x. Then 4 minus 9 would be the same thing. We would get -5. Okay, so it just kind of, I think it'd be funny if somebody was to walk in, or somebody would actually like look at your paper. You would think that you're doing like hieroglyphics or whatever. Okay, but and I do have some students, they will actually, they'll have, I don't know how they do it, this multiple different colors of highlighters, like the small ones that look like pens and pencils, and that's how they mark their stuff. Absolutely fine. Not a problem with that. Okay. Now, this one we have a little bit more room to write underneath. So let's see. What's the biggest? What's the biggest? Huh? Yeah. All right. So the fourth. So it's, yeah, 5x to the fourth. Okay. Now, let's see. The next power should be to the third power. So let's do a little curly thing for the third. And there's no other ones. That's a little squiggle. All right. Now, this is what I have a lot of students, they love to do this because it helps them organize their stuff. They'll do this right here so they can see it a little bit better. Again, totally okay. We would get -4x squared. All right, this one's kind of fun. -6x plus 6x. These would do what? Cancel each other out. You wouldn't have to put a 0. It's not 0x. It's not just x. It's nothing. Okay. It's like what some of y'all do, leave as your answers for the test sometimes. Okay. Or like, I don't know the answer to this, but here's a drawing of a dog. Okay. Or here's a flower. The one this week was, here's a mushroom for your troubles, and it was a really cute mushroom. Okay. All right. So again, we're just combining like terms. Okay. This is stuff you should have had in Algebra 1. Of course, we've all slept. Some people have made poor life choices since then, so you may not remember. Okay. All right. We good through 3? Yeah. All right. Now, there's a couple of ways that you can do this. All right. Some teachers, and I've probably have done it before, will do something where they'll say if you distribute the negative, you can add them, which makes 0 sense, but we do it because it's math. All right. So they'll change this to a positive, and then they'll change all these signs right here. And some people like that. Okay. Now, there was one year I did that in class, and there was a revolt. Like they made T-shirts and everything. Like they were not. No, I'm just joking. Okay, but some people will do this. They'll say this is 4x cubed minus 8x cubed. So they'll really pull them down like that. And I have more students that do this now, and which would be negative 4x cubed. All right. So we got a squared and a squared. So plus 6x squared minus 2x squared. So another 4. All right. This is where it gets fun. You don't think it's that fun? All right. What is minus a negative? Yeah, it changes it to plus a positive. So this actually changes this to negative 9 plus 5x, and you get a negative 4x. I know. Wow, look at all these 4s. And it's on problem 4. Yeah. There has to be a trick. Okay, so here we have another minus a negative. Well, that also turns to plus a positive. So, whew, we got 2. Okay, if it would have ended up all 4s, I think you know Earth would have opened or a wormhole would have opened. We get attacked by the Chitauri and all that kind of stuff. So I've only done it like 1 or 2 times to mess with students like that, but y'all know I don't like do these problems ahead of time, so there's no way for me to really put that much thought into it. Okay, so probably a really good teacher, but not me. All right, so let's look here. It looks like to the 4th. So we have 10x to the 4th minus 2x to the 4th. May the 4th be with you, and you get 6x to the 4th. Oh, wait, 8. Yeah, I'm okay. Just the caffeine hadn't kicked in. My ear infections got me a little loopy today. All right. Okay, I don't need to drink enough caffeine to smell colors. Okay. All right, we have another minus the negative. Yeah, so we plus the plus. Okay, so we get just now. You could write this as 1x to the 3rd. You could not write the 1. But again, if you have to write the 1 so you understand what's going on, please do so. All right. I'm not I know how to do this. I understand how it works. I need to know if you know how to do it. Okay? Okay. Now, the squared. So negative 7x squared minus negative 4x squared. Oh no, another minus a negative. Believe it or not, these minus the negative things would always catch me up on my higher level math classes. Like it would always be like a sign that would be wrong somewhere in the middle of the problem. Yeah, tough stuff. Or it was like that one time where I forgot a step but remembered the answer and wrote the answer and just made up some step. It probably broke like 16 different math laws. But the math SWAT team did not find me. The the math SWAT team called the subtraction division. I like it. It's time for you to be minost. Okay, so moving on to number 6. Got me a little lightning bolt here for the x to the 5th. There's no other x to the 5ths. Now, this is where we lose some people. This is the only use your powers for good instead of evil. Give that back and actually use your own pencil to do stuff. Now, so we're subtracting this, but there's nothing else to subtract it to. It's basically like you're doing this, which would be negative 6x to the 4th. Oh, little curly right here. And you have to do a little curly symbol to the third power. I mean, it's just funny. All right, minus a negative. So, yes, this becomes 13. I heard it somewhere. Some people whisper really loud. All right. No, because it's not in here. So, I was showing how, like, there wasn't an x to the 4th on the left-hand side. Yeah. All right. So, minus x squared. Whoops. All right. So, this would be a negative 3x squared. There's no other x's. No, because it's in the front. It's like 7 minus something. Yeah. Whoa. What? Apparently, I'm trying to write Mahjong characters. All right. And we end up getting 8. Now, so the only thing with this, the more terms you have, the slower you may have to go. Okay, I compared this in the last block is like when you're in a car and the car starts going up a hill, the steeper the hill, the slower it will go because it has to overcome the torque and gravity and stuff like that. So when you see like, hey, this looks kind of busy, you don't need to try to go all the way through it. Okay. You have to kind of step it out a little bit. All right. Remember, there's no prize for turning your test in first. There's no prize for turning in last. I know that always bothered me because I worked slower than other students, and I would see that first, like I would be on number 3 out of 10, and then somebody would turn their test in, and I was like, uh-oh, apparently I'm not prepared. And then I had to think, oh, remember, Jeffries, you work slower. Okay. Yes, I used to have to give myself pep talks. Now, all right, multiplying. You multiply the numbers and add the exponents. Okay, so 5 times 3 is 15. Okay, and we add the exponent, so 2 plus 2 is 4. Whew. Whew. All right. I think if a teacher was to hold their breath until students gave the answer, like this teacher would pass out because students would purposely hold their breath for a long time or not answer. All right, 5 times 7 is 35. This is 2 and 1, so we get 3. And 5 times 6 is 30. And just x squared. Okay, now this is not an Algebra 1 problem. I actually pulled these problems from Algebra 2 handout. Now, I gave space and stuff to do them, unlike they did on that handout. But y'all know the Algebra 2 books that y'all are supposed to have, but y'all have never seen? Yeah. Yeah, I know. I had a parent, they're like, do y'all have textbooks? And I actually found out last Friday that or the Friday we had a half day. I was like, well, I just found out we had textbooks today. I said, but I haven't used a textbook in like 8 years. And I said, plus the students don't have lockers. So if I don't use the textbooks, why would I make them carry it with them? I think it's ridiculous. All right. Same verse, same as the first. So it's the same process. We're just different numbers. So we get negative 20. This looks like to be x to the 7th. I'm going to move my face. Okay. This is a positive 18x to the 6th. Woo. Math lessons now with added sound effects. Not well. Little hairs don't get in my mouth from my mask. I have strings that do. All right, and we had negative 8x to the 4th. Okay, so I better fix that before somebody says, "What is that? Is that a 4?" All right, so and what's funny is we've had a problem like this in our old Algebra 1 test over this stuff, like almost identical. But yeah, it's still an Algebra 2 concept. No, who cares? So, all right. So now this is when people are like, "Oh, this looks easy," and then you get to the next couple of problems, and they're like, "Ooh, they look a little bit different." Okay, and that's okay. They can look different. All right. So you can actually use the double distributive property, or I had a student try this today, and they said, "Mr. Jeffries, if you do it like this, your terms, your like terms end up together, and you don't have to take as much time to find them." I was like, "That's interesting." So this is what they did. I'll share. They cut it like this. They said 8x squared minus 3x plus 1. Okay. And then they went and did this part right here. They also said for some odd reason it just seems like less writing. And I didn't argue with them because I kind of liked it. And anytime I can tell students that it's less writing, they'll try it. So we multiply, we get negative 24x to the third plus 16x squared plus 9x squared not 6x. And anything times 1 is itself. So bloop, 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 bloop. All right. So this is where they really got my attention on this, is because these terms are together and these terms are together. You don't have to really go through and mark them with the symbols and rewrite them and stuff like that. I think that's just why they said it was less writing. Okay. So I kind of like it like that. It's different. Yeah, you could. We're going to do the other one the other way. I'll show you. It really doesn't matter. Remember, in multiplication, the order doesn't matter. So, and technically, there's this way. You could have split the negative 3 and 2 and done it that way. You could have done the box method. There's multiple different ways, and you just have to kind of figure out what works best for you. Excuse me. Didn't mean to burp in the microphone. is that scrumptious lunch of soggy chicken nuggets and soggy baked okra and supposedly no, it was okra. Yeah, it was okra. And then instant mashed potatoes with some type of green flakes on it. Okay, so AstroTurf. What's funny at Alabama's indoor practice facility that's turf, there's actually like it looks like a weed in there because some of the plastic is not sliced up like the other one, so it actually has a broad leaf on it. Yeah, so I've found it. It's we used to go there for cheer camp, so years ago. All right, are we good with number 10? Sure. All right. Now, somebody asked, can you do it other way where it'd be like this, or we cut it like this? And the answer is yes, you can. You, basically, you could just, as long as you're multiplying each term, you're good. Okay. So, if you do it like this, yeah. Remember, the only way to make everybody happy is to sell ice cream. Oh, okay. So we're going off the rails here. All right. So, all right. So that's done the other way, and it's six of one and a half dozen of another. It all depends on how you want to do it. Um, I love it when I show people multiple ways to do stuff. They're like, "Which way should I do?" I said, "Which way do you want to do?" They're like, "I don't know. Tell me." Yes. Okay, I'll get to that. Yes, this handout is a little number biased. Okay, because there's a reason. Because somebody said, "Where'd number 12 go?" There is no number 12 on y'all's handout because the 12 that was on the paper was like, it would have been like half the paper. And it was like, where did they mess up? And it's literally, they didn't do a negative somewhere. And I was like, I'm not doing that. Now, yes, this says in exercises 13 through 16. I only chose two of them. And after we do the first one, you'll understand why. Just wait. It's a cliffhanger. The suspense is so much. I hope it lasts. Now, this is what I would do. If you read from left to right, I would do these two first. Okay? Like so. I would say x and x plus 4 minus 1 and x plus 4. We're just doing this part right here. That's all we're doing right now. What's in red? So we get x squared plus 4x minus 1x minus 4. What? Am I moving too fast? Listen, as being a larger male and somebody say that I'm moving too fast, I kind of take that as a compliment. Yeah, Now, so now we combine like terms, so we have x squared plus 3x minus 4. Sorry, one of my cameras went off at the farm, and I don't recognize who's driving on my property. So, all right. Now, we did not forget about x minus 3. Bloop. Now, you could do it either way that we had. You could split up the x minus 3, or you could split up this right here, like so. All right. So x to the third minus 3x squared plus 3x squared. Woo! Minus 9x minus 4x plus 12. All right. So by doing it like this, we have all of our like terms together. And if you did it other way, you'd have to, do the symbols, something where you could figure out what's the like terms. Our x squareds cancel. So it looks like I'm just left with x to the third minus 13x and plus 12. Ta-da! Yeah. Now do you see why we only have 13 and 14? I mean, I can make y'all do that. Somebody said that they had flashbacks from when I drew the arrow down of doing long division with zeros. That's funny. Again, long division, archaic. You might as well like get a stone tablet and try to chisel in your homework. Okay? It's not. Boy, that would be a headache. A class of 30 students going ting 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 ting. And then what if you messed up? Well, yes it is. Oh, that's the joke. I get it. Yeah, it used to while we were um at when we were all virtual, I'd be sitting here and recording, and my phone would go off, and it was like a very large groundhog was getting into one of my deer feeders, and like it finally got so fat it couldn't climb up into the trough. It was the funniest thing. All right, so all right, we're doing this arrow, but it has nothing to do with long division. Technically, we are supposed to cover how to do long division with polynomials, which again I think is an archaic thing. And I like show one problem, and I'm like, and this is why we don't do it. It is. After this, we have a hand stretching exercise to do. I'm not joking. Like my hand was severely cramping after the last class. Yeah. Yeah. So it's, yeah, it's a lot of writing, but is it going to be worth it? Well, I don't know. Depends on if you want to repeat this class or not. Wouldn't it be bad if you did not pass my course and then you had to end up taking it again with another teacher and then they were like a lot meaner than me? A lot meaner. So much meaner. Oh, I've actually had a student that failed my class and they had to take me again. It was so fun. All right. So that's kind of it for our lesson for today. Good stuff, good things. Roll Tide.